Hi, everybody. This is Mr. Folly, and welcome to Podcast 1.2. We're going to describe the atom through history and talk about the current model of the atom. So let's do it. So basically, the reason why we describe it through history is to show you that history is very important. So you kind of have to make a stand on something and then test it to figure out what's right in today's. Theories change over time, but given enough time, theories are very regular and constant. So we had this theory about that eclipse thing, and guess what? Hey, we were right. We saw a little fingernail blocking out the sun. Ooh, how exciting. Ooh. Maybe it wasn't that exciting, but that's okay. So theories change over time. So Dalton thought atoms were just balls. Well, they're a little bit okay, but incomplete. Thomson thought they looked like chocolate chip cookies. So Thomson worked with electrons to say, hey, these balls have dots in them. Oh, they have negative dots. Hey, look. That's what he added. Rutherford found out that every atom has a positive nucleus. Positive. So that meant the electrons were somewhere else. So we're getting there. Bohr thought electrons were in rings. So we have our nucleus. We have rings of electrons. Electrons, electrons, electrons. And this is what you usually see on TV shows and stuff. And this is wrong. I just want to emphasize that's wrong because what people think is right today, but it's not. So sometimes people show the or whatever it is, and that's wrong. It's closer, but it's wrong. The real model, the real model, I'll put up here, says there's a nucleus, and then there's clouds of probability. And that's kind of what it is. Okay. I mentioned Bohr specifically here because he thought electrons were in rings, which was wrong. But the evidence that he used was used in all kinds of stuff today. So if you look at atoms, you will see these things called spectral lines. And this is a specific spectral line for a type of atom. And if you look at this, could you imagine how if I had something like this, it would look like a barcode? And the work that Bohr did allowed us to have the work of barcodes. And if it wasn't for barcodes, we wouldn't have the giant mega stores that we have today. Department stores used to have departments, and if you bought shoes in the men's shoe department, you could not return them to the sheets department or whatever, what is that, bedding department. You could only go to that certain department because it had to be segmented because things had individual price tags. Once they figured out how to do these barcodes, they found out how to have the scanners, and all you need to do is a bloop, 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 and that's it. So this research of silly atoms gave us scanners and makes shopping cheaper and easier. No, we didn't need that at all. Sorry. The current model is that quantum mechanical theory is correct. The quantum mechanical theory is correct. The quantum mechanical theory is correct. The quantum mechanical theory is correct. So you need to remember that. Electrons exist in clouds, which we call orbitals, and we can predict where they probably are. The Heisenberg uncertainty principle, we either know the direction or location of the electrons, but not both. So we call the electron paths orbitals rather than orbits because we don't know. Rings are rings of rho. These are some of the weird shapes of the clouds. See how it's like, what shape are you going to call that? It's a donut with a little nubby mud. Yeah, see, so that's why we just call them clouds. Just to remind you, protons in the nucleus tells us the identity. Electrons are in clouds, not rings, clouds. They determine chemical reactivity and charge. Neutrons in the nucleus tells us stability and mass. And this is an awesome podcast because we're all done. And this part, actually, you don't even need to know it. Woo-hoo-hoo! And I'll say this to you, toodles to the best podcast because it is fast.